Well, hello everyone. Firstly, I apologise that you've got to put up with me for a little while. Andy's running a little bit late, but he'll definitely be along later. Please forgive me if I muddle my words. I'm definitely not match fit today, so you'll have to put up with me for a little while. Um, and again, also, we apologise for what happened last week. Keith performed a wonderful task and presented a wonderful presentation. We enjoyed it, but unfortunately, you didn't. It was a problem outside our control. It was actually to do with Restream, and that's why you lost the connection. But never fear, because Keith has bravely stepped into the forefront, and he's going to redo his presentation again. So no, you didn't miss anything. It was we enjoyed it, but you'll be able to enjoy it tonight. And apparently, he's adapted it so that we don't get bored. That's very, very kind of him. I'd also like to thank everybody for buying us coffees, as you well know. The coffees go towards making us help us make these shows and also the other presentations we do. So we're very, very grateful. It also keeps us awake when we're up to do live launches. I don't know if anybody was with us. I know Ian was. Last week we had to get up twice very early because the first time we were going to watch a launch, they scrubbed it and we were already on air. So we were 2 days, we were very, very tired. But yes, thank you, Ian, for joining us and others. It was a good show. But then again, also the Gremlins hit us on that. So just as the launch was about to happen, the computer and his computer went down, and we lost the stream. But we were able to watch the replays, and but yeah, we had a nightmare week of Gremlins all week. So again, as I said, thank you for the buyers and coffees. I'll just pop up the things if anybody would like to scan the code. And we can, if you'd like to buy us a coffee, we'll be very, very, very grateful. Thank you very much, whoever just scanned the code. Also, I'd like to mention Lou says he's lost audio, so he's just popped off to come back in. Oh, it's back now. So, but we've got no Lou on the screen. Anyway, sorry about that. I get. It's not my day. It's not my day. I'd also like to mention our merchandise, as you know, we've already expanded our merchandise, as well as usually we've got the normal T-shirts. Now these are £20, and with this you've got the logo on the back. But these are £20 plus. That's including postage and packaging. It's £10 extra for orders overseas. So that's the standard T-shirts. We also got the new Lapel design T-shirts where the design is actually on the lapel. This comes in two types. We have the standard T-shirt, and we have a long sleeved version. That's for the gentlemen that are getting old in age and they need thermals. So it comes in two styles: a T-shirt or a long sleeve T-shirt. And finally, but not least, we have the Space Oddities hoodies. These come in two styles also. You've got the over the head style where the logo is on the front, and then we've got the zip up style where the logo of course is on the back. And as it was, we will be expanding our merchandise even further. And somebody did request a sweatshirt. But as one of our other viewers suggested, we'll just buy a hoodie and cut the hood off. So that will resolve that situation. The hoodies are they £35 now, Michael?
I think so, yeah, £35.
Yeah, £35 again, £10 for excuse me, for overseas postage. But yeah, okay then. So that's them. That's all the you should know. We've got a great show for you this week. First of all, let's go around the panel. Roger, how are you?
Oh, I'm all right. I'll survive.
Oh, okay then. Deep joy. Right, Michael. I see you're still nursing your thumb.
Still got the thumb for another week, hopefully, and That should be okay.
Well, you're just keeping the thumb for another week, then you're sending it back, are you? Okay, that's fair enough. What is it, Lego? So, and Keith, hi Keith, how are you? How's place weathered in your way?
Been nursing a cold, but apart from that, I'm okay. Yeah.
There's so much going around. Well, this is doom and gloom. This is
at the bottom of clouds for about the last week, so I haven't been out and seen.
Dear me.
Yeah.
This is all doom and gloom today.
I know.
Blue, raise our spirits, please.
I'll pick it up a bit. Doing well. Coming to you today from the frozen north of Minnesota. Visiting family out here. So
is Minnesota, is that the same as the soup? Oh no, that's minestrone. Sorry.
It is not.
Yeah, sorry.
We'll work on your geography later.
Well, you told us we can't read.
I'll show you pretty pictures. It's okay.
Okay then. Thanks again. We've got some. Lou's going to be giving us a presentation later on about asteroid Bennu and its makeup. And again, as I said, we've got Keith doing our astrometry. Astrometry, yeah. Thank you, Roger. Roger's working me. He's got me hand up my back. Yeah, thank you very much. Right, so with no further ado, let's bring Roger in and let's get what's going on in the night sky this week. Oh, sorry, I've just turned you off. Sorry, go. Right, leave it alone.
Right.
It's gone again.
Oh, I'm on the wrong one. That's it. There we go.
Right. Okay. So here we go for the 20th to the 26th. So we're coming up to the end of the second month of 2024 already. So as we can see here, we're going to be working our way up through to the weekend with a full moon. So it's bound to be clear skies then. Probably not until, but there we go. And a couple of nights ago, this is what I could see in the night sky, which didn't look too bad, but that was all I could see through the horrible cloudy weather that we've had in the last week or so. It's turning out to be weather again from 2023, I think. I hope not, but there we go. So here we go for the 10 o'clock through this week, and yeah. So we've got Jupiter still in the western skies, Orion now passing over Meridian, and the galaxy season coming up with Leo and Virgo coming up from the eastern horizons. And as you can see, we got that pesky full moon dominating the sky. But during the hours before sunrise, we've got two planets, Venus and Mars, very low on the horizon. And on the 22nd, they have a conjunction. And through the week, they almost sort of level on the horizon coming up together. So that would be a nice sight to see. But I would think the bright sunlight coming up through at the time that they're coming visible, very low on the eastern horizon, they will be very difficult to see. So probably binoculars if you're very careful. So, but we've still got some comets of interest. Pons Brooks is still heading on through the system, and it's heading towards Andromeda. And it's still brightening up, and there are still some interesting comets like this one. This one I haven't mentioned just yet. This is Comet 13P Olbers, and that's coming up through into Taurus through the early parts of April. But the forecast is for that to be quite a bright object, but that will be sometime later in the year. But obviously, as it will be going through some of the winter constellations, it might be more for the southern hemisphere to get the benefit of a naked eye comet, unfortunately.
Yeah.
So, but it is a bit faint at the moment, but we shall see how that goes. So here we go. here we are for our gallery for this week. We've got a contribution from David Garside again, and one of his images of Jupiter. And here we go. And we've got one of the moons there. I don't know if he's hasn't put which of the Jovian moons we've got, but very good effort from Dave.
A nice image considering it's a Dobsonian untracked.
Yeah.
Yeah.
Very nice.
Very good. Quite impressive. And another regular now, we've got Keith Maslin with his 11-inch edge of... let's have a look. Oh, it's the Crab Nebula.
Crab Nebula. That's lovely, that is.
Got lots of interesting structure in that one.
Yeah, if you go online, and I think it's actually a Wikipedia post, you can actually see from I think it starts in the 60s up to the present day, you can actually see how this has expanded over the years. And it's quite remarkable how much it has expanded, how much bigger it is than when we first noticed it, started taking images of it in the 60s. Thanks, Rog.
Okay. We've got another regular, Jerry DeLay, of the Spider and Fly Nebula. Not sure about that one, but there we go. That's
in
his, and we have got this structure.
Whoa, that is something special.
It certainly is.
It must admit, it's not one I've heard of before.
No, I'm not aware of it. Whether it's got its other name from something else, I'm not sure. But anyway,
that is something special. Yeah.
Oh,
here he is.
Here he is.
You just have
what's a gallery without some of my images in it? I say.
Good.
Good gallery, I think.
Yeah, I heard that. So one of my images of the last week of the first quarter moon from a few nights. I think that was on the 16th.
Okay, that's a nice.
Got some nice detail on that one. Yeah,
very nice.
Haven't quite got the lunar V and the X. That obviously needed just a few more hours to get to that part.
Is this a stacked image, Roger?
It is, and it's not with a C star.
No, you can tell it's not good enough.
And we have the sun from today. Now, we've got some very large sunspots coming across at the moment in the last day or so. So I've included a close-up of that. And
that is a big one, isn't it?
It is quite big. You could probably get a few, about 2 or 3 Earths in that central dark area.
Real problems if it decided to get spunky right around the center of the sun.
Yeah. I mean, the sun has been. I think I'm up to the 19th. Has been very, very active. But as you can see, most of this, whereas about a week ago, the sun's face was absolutely covered in sunspots. It's now virtually devoid of them. Just a couple of big ones now left on there. But the one that just went off the limb to the right the other day, that was firing all the way across. But because it wasn't on the equator, it didn't really give us much in the way of space weather. But I have noticed that using the satellite images using a coronagraph, which is where you just blank out the actual sun, where you're looking at the corona, the far side of the moon has been very, very active to the last week or so. It's probably some of them that I've seen explode off the back there. Probably was a good job that they were on the far side, or else we could be having some really nasty problems, like losing Space Oddities. The dark side.
I would. Yeah, I would have.
It's where we're going to land. It's where we're going to land because it's colder.
I don't know.
Yeah, I would have done some hydrogen alpha this, but it's just too cloudy to be able to use a chromosphere on that. Unfortunately, it'll be interesting to see how active it is round there and see whether
Yeah.
we do get
You can
any
see it's quite a
flaring
big
out.
area because you can see these lights, veiny areas around the outside, which is magnetic activity that's happening around these spots. Of course, because these are actual magnetic loops that are actually pushing their way up through the actual surface of the sun itself, the coronosphere, and they rise up like a submarine coming up through the thing, and of course then they start all interacting, and you get your big loops and things like that. But you also get this big area around the outside of magnetic activity, which is called the plage. Yeah, sorry, Roger.
That's all right. So that concludes the gallery.
Oh, thanks for that, Rog. Short but
okay.
sweet. Short but
Yeah,
sweet.
well,
But
we had a few
yeah.
entries.
Yeah,
so
that's
I
good.
just
No,
topped-
that's lovely. That's
So
lovely.
I just topped it up.
Yeah. Okay, then that's great. Yeah, thanks for that. Yeah, as I said, the sun has been very, very active. We're looking possibly into doing excuse me, looking into doing some sort of solar weather activity over the week presentation. We don't know whether we'll do it as an independent show on its own, or whether or not we'll incorporate it into the main show here, the live show. But we're working on it. We've got to decide what the format's going to be at the moment. I mean, we've got loads of data already, so it's just stitch them together and then find out what format we're going to go. So anyway, thanks for that, Rog. That was great. So I think next we'll move on to Keith and a repeat of his presentation from last week. So if you just bear with me while I find, there you go.
Right, fantastic. Thank you very much. Right, this is not an exact repeat of last week. I've augmented it and changed a few things. I'm going to talk about the science of astrometry, which is the process of measuring distances and things of that nature in the universe. You're not a proper scientist, unfortunately, unless you measure things, and you're not really going to go far in astronomy professionally anyway, unless you're good at maths. But don't let that put you off, because in fact, I'm going to keep things fairly straightforward. And I did note somebody last week asking me in the forum to explain something a bit better. So I'll do my best, and we'll move on from that. So, okay, let's start off from the beginning. As I said last week, it's a myth that when Christopher Columbus set off across the Atlantic Ocean, that everyone thought the world was flat. Everybody knew, including Columbus himself, that the world was round. In fact, that was the point. Columbus thought that he could, by sailing west, arrive in the Asiatic region by going sort of around the other way. What Columbus didn't know, and a lot of people at the time seemed to not know, was actually how big the Earth was. Strangely enough, the work of Eratosthenes and Al-Biruni, who'd measured the circumference of the Earth quite accurately, had somehow been lost, and they thought the Earth was smaller than it actually was. Interestingly enough, of course, when Columbus arrived in the American region, or to be precise, the Caribbean, of course, the people he met there, the settlers, the original indigenous inhabitants of the islands there, were in fact people who'd emigrated into North America and that region about 20,000 years earlier via the Bering Strait, and therefore had an Asiatic appearance. So Columbus understandably thought he had arrived in Asia rather than where he had actually arrived. Anyway, that's another story. The thing is, though, that about sort of 200 years later, there were in fact actually a lot of myths put about that medieval people were, thought that the world was flat, and it was a kind of insult directed towards Catholicism, which was the dominant religion prior to the Reformation. Well, you can still be a flat earther today if you want to join the Flat Earth Society. You presumably get a certificate that looks a bit like this one. rather fascinating. And you'll probably notice the bottom left there, you can see there's a picture of what they think the Earth looks like. And in fact, it's essentially a conical polar projection of the Earth. And you will see that sort of thing in atlases, but they've interpreted it as the Earth being flat. I'll come to that in a minute. And here's another flat Earth document. This dates from the 1890s. And in fact, an awful lot of flat Earth stuff seem actually to have popped up in the 19th century. It does seem to be very much a 19th century thing rather than older than that. And you can see here, this was issued by a Professor Orlando Ferguson from South Dakota. The previous one, by the way, is marked up as California. But in case anyone's feeling smug and assuming that more Americans think the world is flat than not, apparently the larger percentage of British people are flat earthers than Americans. So that's a statistic I picked up a few weeks ago. And here is a flat Earth map of the world. And as I say, what it is effectively is a conical projection looking down from the North Pole. And in fact, you do see legitimate maps like this in atlases, but it doesn't imply the Earth's flat. It's just simply a way of projecting the appearance of things from a certain angle. Anyway, we'll move on in a minute to actually one of the most notorious flat earthers, a chap who went by the pseudonym of Parallax. And you can see the book top right there is marked Parallax. And in fact, actually at the very top of the book, you can see the word zetetic astronomy, which is something, a thing he invented. We'll come to that as well. Right, okay, so of course, it's easy to ridicule flat Earth today, and of course there are lots of jokes out there like the ones you see here, but let's have a look at some of the arguments that these people put up. These are some facsimiles from journals issued in the 19th and early 20th centuries by flat Earth proponents, and actually there is a Flat Earth Society, and I did get these off their website. The one in the middle dates to 1897, the one on the left 1885, the one on the right 1870. So you can see a predominance of 19th century works here. And again, you'll see that word again, parallax, look, see, on the right-hand side there. Who is parallax? Well, you see, there was an experiment conducted in the early 19th century by a man who went by the pseudonym Parallax. And basically, it was called the Bedford Level experiment. And basically, he went to a river in Cambridgeshire, in the Fens. And the Fens, as most people know, are incredibly flat and indeed virtually at sea level, if not below it. And you can see on the left-hand Google Earth image there that the river we're talking about, which is being channeled and canalized, runs from bottom left to top right, and runs through a place called Welney, which is more or less in the middle of the map. And on the right-hand side, you can see a view from the bridge at Welney using Street View on Google Earth, and you can see how flat that river is. Now, the argument went that if the world is curved, and somebody is several miles down that river cum canal, then they will have disappeared over the horizon and it will not be possible to see them. And indeed, back in 1837, I suspect that structure, you can actually see in the picture there, wasn't in the way. If the Earth is flat, on the other hand, then you will be able to see a distant object many miles away because there's no curvature to make them disappear. Well, that was the idea anyway. So basically, Parallax was a man called Samuel Burley Rowbotham. And he claimed that if you had an object 10 kilometers down this river, you'd only be able to see it if the Earth was flat. And here's some diagrams from his original work on the subject. You can see the one at the top there depicts what would happen if the Earth was curved. You wouldn't see the man in the boat with the flag. And if the Earth is flat, then you do see the man in the boat with the flag. And his argument was, well, I could see this bloke 6 miles, 10 kilometers away. Therefore, the Earth must be flat. But in fact, actually, he hadn't taken something into consideration, and that was atmospheric refraction, that the air in the atmosphere bends light rays, and so objects can be seen over the horizon up to a certain point because the light isn't traveling in a straight line. And in fact, his theory was retested later on at Welney, and when the numbers were crunched a second time round, allowing for refraction, it showed that indeed the Earth was curved, and he was wrong. So in fact, he was put up for a second test, and they went to Plymouth Hoe and looked out towards the Eddystone Lighthouse, which is 14 miles away. And the argument was that if the Earth was curved, then you would only just be able to see the top of the lighthouse. And in fact, he said, no, you'll be able to see all of it because the Earth's flat. Well, when they looked through a telescope at Eddystone Lighthouse, they discovered that indeed only the very top was visible. In fact, even less than they'd expected, proving that the Earth indeed was curved and it was largely below the horizon. But interestingly enough, Rowbotham, who was a sort of pretty pugnacious individual, refused to accept their finding and said he was convinced from what they were seeing that in fact the Earth was flat, even though it was the opposite of the truth. Rather strange, I think you'll agree. He was an interesting character. He actually invited several people there, and in fact, actually, some famous scientists of the day, astronomers and other people. And as I say, even allowing for refraction, or rather allowing for refraction, the Earth really is curved, that the light is bent, as shown in the top right diagram on this screen here. So when the sun sets, you see it a bit later than you should in a way, because the light from the sun is being bent over the horizon. So you see it setting. One thing you also see, of course, when the sun sets is it begins to become more oval in shape because of the atmospheric refraction. And indeed, this is the case even for the moon. If you look at this picture at the bottom center, this is a picture of the moon taken from the space station. And you can see that it looks like it's a gibbous phase to the moon. But if you look carefully, you can see Mare Crisium, that small, round, dark patch top right of the moon. And that, of course, is right at the right-hand side of it. That's a full moon. But the right-hand side has been squashed by atmospheric refraction. So that's not a gibbous moon at all, but a full moon. And the refraction actually also causes dispersion. That is the splitting of white light into component colors. The top right picture here shows two planets, which I took with a telephoto lens. The bottom right is Jupiter. The top left is Venus. And if you look carefully at Venus, you can see it's a little bit red at the bottom and a little bit blue at the top, because the light from Venus is being dispersed by the Earth's atmosphere. And in fact, actually, astronomers who study planets at low elevations do have atmospheric dispersion correctors fitted to their telescopes to get rid of that effect. Well, Rowbotham is one of those sort of scoundrels that you hear about from time to time. He married an infant bride, managed to get her pregnant 15 times. 11 of them died in infancy, which actually was not entirely surprising for the period. Child mortality was pretty high. But more suspiciously, he was named in numerous cases of wrongful deaths, including a death by misadventure for accidentally poisoning one of his own children. He was named responsible for other deaths because he was a quack, a believer in miracle cures, and he was using phosphorus. Anybody who knows anything about phosphorus will know what an incredibly dangerous chemical it is, an element rather. And so you can imagine he was completely off his trolley using that. Anyway, there we are. An interesting guy. He also patented an invention including a life-preserving cylindrical railway carriage. It adds a sort of ring of sharpening knives under pyramids, doesn't it? It's got a crazy idea. Anyway, needless to say, he was unqualified, and he described himself in various ways, all of which were inappropriate because he didn't have the skills really, except he might have been a soap boiler. Well, we know the Earth's round, of course, and a lot of you have no doubt seen that logo on the right-hand side of the slide here. You know, it's not flat. Yeah, we checked. And of course, this picture here, which I think was taken, yeah, it was an interplanetary probe getting gravity assist from the Earth, clearly shows the Earth to be round. But there are various other bits of proof like circumnavigation and indeed other things. For example, at the top there, you can see pictures of wind turbines taken with a long telephoto lens. And you can see the further away they are, the lower below the horizon they are, because the Earth is curved. So that's that. And on the bottom there, you can see a sequence of images of the moon as it passes through the Earth's shadow during a lunar eclipse. And you can see the shadow is round. The shadow is also fuzzy, of course, because the Earth has an atmosphere. And indeed, you don't have to go into space to see the Earth is curved. The picture on the left-hand side there, which I've deliberately put on sideways to show the effect more clearly, is an image taken from an Airbus airliner over the East Mediterranean. I'll put a straight line in there so you can see that the horizon is curved. And the right-hand picture is even more noticeable. This picture of Concorde, which of course flies at an even higher altitude. You can see the Earth is curved in the background. And of course, if anybody says it's a distortion due to the lens, you can see that Concorde is actually not banana-shaped. It's straight. So therefore, the picture is not distorted in any way. And here are pictures, a photo montage of pictures taken from an early rocket launched in 1948. This was a V2 or A4 rocket, a Werner von Braun rocket, with an extra solid fuel rocket stage attached to the top, called a corporal. And using these rockets in the late 40s, Werner von Braun and his team in the United States were able to take pictures from quite high altitude. In fact, I think I'm right in saying they were getting up to altitudes of 500, 600 miles, which actually is significantly higher than, say, the space station orbits the Earth. So the space age didn't start in 1957 with Sputnik. People were going into space before that. The difference was that Sputnik, once put into space, stayed up there, or at least for a while anyway, because it had sufficient velocity to stay in orbit. Whereas these early rockets, taking the pictures you see here, went up and came back down again. And in fact, one of them landed in Mexico, which caused a bit of an international embarrassment. And Werner von Braun was consulted about this and didn't seem awfully bothered about it, really. But there you go. Yeah, there was a song about Werner von Braun saying, rockets go up, but where they come down is none of my concern, said Werner von Braun. Anyway, there we are. Now, as I said, if you're going to be a scientist, you've got to measure things. And I'm going to start with Aristophanes' experiment from about 300 BC. And in fact, it's really blindingly simple when you think about it. It's surprising no one thought of it before. But basically, if you stand on 2 points on the Earth's circumference, then the distance between those 2 points is part of that circumference, part of the great circle surrounding the Earth. So if you know the distance between these 2 points, and you can measure the angular difference between these 2 points, you can then work out how much distance in total you need for a full 360 degrees all the way around the Earth. And of course, it's simple geometry that if you can find one place where the sun's rays descend vertically onto the surface, and then find a second point where you can measure the angle of the sun's rays, then you're part of the way to solving the problem. Now, Aristophanes knew there was a well at a place called Syene, which today is Aswan. It's a big well. You can get a double-decker bus down it. And in fact, at midday, the sun at certain times of the year would shine vertically down the well. At the very same time, if you put a stick in the ground or any vertical object at Alexandria on the north coast of Egypt, then it would cast a shadow. And the angle that the shadow makes with the stick or the column, which is angle theta in this diagram, is by geometry the very same angle as the angle between the two places subtended from the center of the Earth, which you can see at the bottom left of the diagram. So we can find out that angle theta, and we can measure the distance between these two places, and we therefore can work out the total 360-degree distance for the entire Earth. It's blindingly simple. And the only flaws in this method actually is getting that angle measured accurately and measuring that distance accurately. Apart from that, the method is flawless. By the way, there is one assumption. I'm just going to skip back. There's one assumption that the sun's rays are parallel at Syene and at Alexandria, of course. And because the sun is so far away, they are effectively so. Now, the distance between Alexandria and Aswan as it is today is just a little under 500 miles north to south. And in fact, if you feed that information into the formula, along with the angle between the two places of 7.2 degrees, then you can work out how a full 360 degrees works out in terms of distance. And I've done the calculation, and there we go. And in fact, 7.2 degrees divided into 360 gives you 50. So what we're saying is that the total circumference of the Earth is in fact 50 times the distance between Alexandria and Aswan. And if you multiply the two together, and by the way, I put the wrong number in there, it should be about 500, not 528. You get a distance for 360 degrees, the total circumference of the Earth, of just under 25,000 miles, or just under 40,000 kilometers. And of course, a lot of you will remember from school that the circumference of a circle is equal to 2 pi times the radius. So you can find the radius, and the radius of the Earth is around about 6,300 kilometers. So he had worked out the size of the Earth pretty accurately. And therefore, one wonders why by Columbus's time this information had been forgotten, but it had, and the size of the Earth was miscalculated.
Sorry, Keith, but did you say that in your last slide that he actually, to measure the distance, he actually got somebody to walk that distance, 500 odd miles?
The thing is, actually, there's various theories because nothing's written down about that. And the bottom line is Aristophanes probably had sufficient money to pay someone to do it for him. Or maybe he had slaves to do it for him, we don't know. But also, there, of course, there were camel trains moving between Syene and Alexandria. And they would know the distance anyway, because obviously it was important to them to know that. And there's something else, of course, which I haven't mentioned. And that is there's a bloody great river between them, the River Nile. And of course, there were lots of boats moving up and down, you know, between the coast and further inland. So there were various ways of measuring it. Nobody knows what actually happened, though. Yeah. So we're a bit in the dark about that, I'm afraid.
But he gave it a good shot.
Yeah, but he gave it a good shot, and he got the distance pretty much right. And by the way, of course, one of his predecessors, Aristotle, who was Alexander the Great's philosopher, knew the Earth was round, and Alexander the Great himself knew that. He knew when he moved through Persia and into Pakistan and India that if he kept going eastwards, he would eventually go all the way around and come back to where he started. He knew that. The only thing he didn't know, because there were some oceans in the way. But nevertheless, you know, people knew the Earth was round, and they knew from Aristophanes' work pretty much how big it was. Anyway, there we go. Right, so that's that. And now we move on to Al-Biruni next. Now, this is an Islamic scholar from about 1,000 years ago. And Al-Biruni used trigonometry to sort out the Earth's radius. He measured the radius directly rather than the circumference. And the wonder of his method is that he was able to do it from a single observation point. It didn't require anyone walking between two places or anything like that. He could do it from one place. And what it boils down to is this. First of all, you need to stand on a hill, the height of which you know. And in fact, actually, and I'm not going to go through that in detail at the top there, but you can determine the height of a mountain from two positions on the ground if you know the distance between the two positions and the difference in the angle as you look towards the summit of the mountain. And that's the formula top left there, gives you the height. But the thing I really want to draw your attention to, because it's simpler really to understand, is that if you look at this diagram carefully, you can see that you've got a right-angled triangle. And the right-angled triangle is from point A to C to O. And A, of course, is the viewpoint position on top of the mountain there. And if you look at the triangle, the line AC is the opposite side of the triangle, the right-angled triangle. C to O is the adjacent side of the triangle. And of course, O to A is the hypotenuse of that triangle. Now, O to A, of course, is the height of the mountain, H, added to the radius of the Earth. So if you can solve your triangle to find the hypotenuse and then subtract the height of the mountain from the hypotenuse, then you're left with the radius of the Earth. So what Al-Biruni did was he stood on top of his mountain of a certain size and sighted the horizon, i.e. looked from A towards C, and checked the angle of his sighting relative to the horizontal. And the angle between them is angle alpha, which you can see there by the mountain. But the clever bit now is that if you know your geometry, that angle alpha, which he measured, is the same as the angle alpha at point O on the right-angled triangle. All you've got to do is say to yourself, well, okay, the cos of alpha, the cosine of alpha, must be equal to the adjacent, r, divided by the hypotenuse, r plus h. Now, what I've written this at the top, it's the first line there. And then what I've done there is just simply do a bit of jiggery-pokery with the algebra. And it's not really necessary to do that, but I tidied it up. And then you put the data in. And from a 240-meter hill, the angle to the horizon from A to C is a half a degree, 30 minutes of arc. And if you feed that into your formula and the height of the hill, then you end up with an answer of 6,300 kilometers, which is pretty much spot on what the radius of the Earth is, slightly on the small side, but not bad at all. The only difficulty with this method is measuring that angle alpha accurately, because it's quite a small angle. Half a degree is really pretty difficult to measure. But it's an absolutely brilliant technique, isn't it? It's absolutely fantastic.
Yeah.
And most people have never heard of him, including this guy down the bottom right here, who about 800 years later, or 900 years later, is saying the Earth's flat. And there you go. So basically, the Earth isn't flat, even though in Monty Python films, and this one won't play, I don't think, so it doesn't matter. But some of the people might remember in Monty Python's Meaning of Life that at the beginning there was a strange sketch about the Crimson Assurance Society, which had turned their office block into a pirate ship, and it falls off the edge of the Earth at the end. That's what you would have seen had this run, but never mind. Anyway, but the next episode I'm going to do of this is measuring the solar system, and to show you how, thanks to Copernicus, we knew that Jupiter was 5 times further away from the sun than the Earth. How, in order to find the distance from the Earth to the sun, we needed to look at the transit of Venus from 2 places in the world, which involved a long voyage to the opposite side of the world. And also how we measure the distance to the moon by using effectively what's a large bicycle reflector, or 3 of them to be precise, left on the lunar surface by the Apollo astronauts. Thank you very much.
Oh, thank you, Keith.
Thank you very much, Keith.
Yeah, you do.
Yeah. Good evening, viewers. Sorry, I was delayed at work, but that was superb, Keith. And all of the trigonometry there, logical stuff. You can just work it out logically that it has to be true, and very real thinking there. Very clear thinking. So it's a shame, really, that the guy in 1993 thought the Earth was flat and had forgotten the tradition of the great Islamic scholars, which is a shame, really. But there you are. So how is everybody?
Fine.
We're here.
Well, don't all sound so excited. Yeah. Oh, Michael's still got his thumb in class, Beth.
Yeah.
That's what happens when you suck your thumb, kids. Don't do it.
Well, the thing is, when we first started the show, you would have thought you were in a casualty department. Everybody's got ails except for Lou. He's he was in Minnesota at the moment.
Yeah.
Do as we say, not as we do.
Mm.
Well, he is rather isolated from us, isn't he?
Yeah.
I've still got this cold that I've had for 12 days now, and it just won't give up. But I'm very generous. I've given it to my daughter. So
Yeah. Think of the family. That's it.
She can never say I don't give her anything. So she's been off school today with that. She's going back tomorrow, though, although she doesn't know it yet. She's definitely going back to school tomorrow. Can't have her missing school because of a cold. That's not quite the ticket faulty. So there we are. Okay, so
Ian says we're all feeling a bit blue.
Yeah. And yes, very true, Ian. I'm not green anymore. I don't know what happened last week. I turned into the Incredible Hulk, and not for the first time either, I might mention.
Incredible.
Or was it Shrek?
It's Shrek.
less of your lips,
Princess Fiona.
Right, I'm going. I'm sorry. I didn't get insulted. I'll go somewhere else for that. So there we are. All right, moving on. Shall we move on to Lou next?
Yep, that'd be great.
If you're ready, Lou.
You want to pull up the slide set?
Yeah, 1 second. And there we are. Okay, there you go.
There we are. Okay, well, so for all of you who are feeling blue out there, this is really exciting stuff. We're talking about the search for origins of the solar system and what brought life to Earth and perhaps other places. And one of the methods that we use to explore that is we send satellites out to asteroids. And we did such a thing with the OSIRIS-REx spacecraft at asteroid Bennu. And it pushed on the surface and disturbed the surface and collected some material from Bennu. And then it flew it back to Earth. And that sample was collected back in September of 2023. And then, of course, OSIRIS-REx wasn't done with its mission. It's now on to 99942 Apophis, also a near-Earth asteroid that presents that's caught our attention, I'll say, in terms of possibilities that it might collide with the Earth someday. So we have these samples now from asteroid Bennu. And here's a picture of asteroid Bennu from the OSIRIS-REx spacecraft. And by the way, OSIRIS-REx stands for Origin, Spectral, Interpretation, Resource, Identification, and Security Regolith Explorer. And I think half of our tax dollars went into figuring that out. Asteroid Bennu. Well, what's the big deal here? Bennu is a near-Earth asteroid. Call it an NEA. And by the way, we don't hear a lot about this, but there are also NECs, near-Earth comets. And these are both small, what we call small bodies in the trade. We call them small bodies that are Earth crossing in their orbits and have some potential, we'll just say, for coming near or colliding with Earth. So we watch them carefully. Bennu has a diameter of about 510 meters. It has a density of about 1.3 grams per cubic centimeter, and that's an interesting number. As we measure the density of moons, say in the outer solar system, we get darn close to 2 grams per cubic centimeter, which indicates less rock and more water ice. And it also has an albedo of only about 4%. So this thing is super dark. This thing is darker than coal. Okay. And so we wanted to go out to this carbonaceous chondrite asteroid, Bennu, to find out what it's made of, to give us some ideas of how the solar system formed, and also perhaps to give us some data, some information on how we can deflect such an asteroid if that day were to come. And by the way, the odds of Bennu hitting the Earth sometime, let's say in the next few decades, is only about 1 in, say, 3,000 or so. So not to worry about Bennu. Now, Bennu is a carbonaceous chondrite asteroid. Let's see, let's go back and stay with that slide. Bennu is a carbonaceous chondrite asteroid, and we have measured, we have spectra and as well as sample returns of other carbonaceous chondrites in the past. And so we know that they tend to be full of water, although they can form dry as well. And this is, as we'll see in a few moments, this has to do with where in the solar system they formed. So up to about 22% water by weight, depending on the location it formed in. These are pieces of the solar system that did not differentiate. They were not part of something larger where the heavy stuff sank to the center, all the heavy metals, and the lighter stuff floated to the top. So these are actually quite old, near the very beginning of the formation of small bodies and protoplanets in the solar system. It's called a carbonaceous chondrite. Well, it has a fair amount of carbon in it, and we certainly see that spectroscopically with Bennu. And it also has chondrules, which are solidified droplets of silicate magma, and so hence the name carbonaceous chondrites. These solar system bodies may have been altered by water or heat. And we know from other spectroscopy that they contain organic compounds. We see on their surfaces, we see olivine. Olivine plus water equals serpentine. We see magnetite, which is just iron oxide. And we see pyrites, which are iron sulfides. So sulfur, iron, water, all of these things appear to be present. So let's take a look at the OSIRIS-REx sample. Here it is at the Johnson Space Center Astromaterials Lab. This is where all materials collected in space are brought. And I have been there. I've talked to some of my colleagues there and seen their facility. It's this enormous clean room where they take extreme precaution to make sure that there is no polluting of the samples that we get back, and we can be certain that whatever we find, in fact, came from the asteroid or the solar wind or the lunar surface or whatever it is that we're looking at. And in fact, they keep some of these samples for quite some time, waiting to open them, waiting to analyze them, waiting for better technology and techniques to be developed so that we can get even more information. So here we have a picture of the OSIRIS-REx sample collection module. I think as I remember, it's about 70 grams of material, which I think is a record for the amount of material brought back. And you can see it is in fact dark material. And when they opened this up, there's a lot more analysis to be done, but they were able to do what they call a quick look analysis, where they took a scanning electron microscope, an infrared spectrometer, X-ray diffraction spectrometer, and were able to analyze some of the sample. And in this analysis, we find carbon, we find water and water-bearing minerals, we find some organics. None of this is a surprise. We have known for quite some time that asteroids not only contain water, but contain the types of water that we find in our oceans, our Earth oceans. Okay, so let's talk a little bit about that for a moment. I think that's the next slide. Let's see if I'm right. No, it's not. All right, let's skip this slide for a moment. Let's just keep going. Okay, there we go. So let's go back to the solar system formation 4.6 billion years ago. We now know we have inner planets. So we have outer planets, terrestrial planets, Jovian planets, and they're very different. And one of the big reasons that they're different is the sun. The sun was very active in its early formation. It was a T-Tauri star. And not only was it hot in the inner solar system, but the solar wind is blowing quite strongly and blew a lot of the lighter materials, such as hydrogen, such as helium, out into the outer solar system. Now, what's important to note here is that out at about 4.5 AU, which is a little bit outside the orbit of Mars, there is the water frost line. And so inside that distance, water cannot form, cannot condense, all right? And at these very low pressures, we can have water as a gas or a solid, but not as a liquid. So once you get past that frost line as you're moving into the outer solar system, then water can condense as an ice. And so we see this. We see this all the time. We call these the moons of the outer planets, icy moons, because there's so much water. Again, their density is about 2 grams per cubic centimeter, indicating they have lots of water ice in them. But we believe that the Earth and all the other terrestrial planets formed dry. In other words, water could not condense in the inner solar system inside 4.5 AU. So where did the water come from? It is widely believed now that it came later from comet and asteroid impacts, as well as perhaps from volcanism from inside the planet. We have looked at a number of comets, and we see that the type of water that comets have, at least on their surface, right? We don't know what their bulk composition is, but on their surface, is different than the kind of water that we have on the Earth, in the Earth's oceans. And this is measuring the deuterium to hydrogen ratio, deuterium being a hydrogen atom with an extra neutron. And on Earth, there's about a factor of 100,000 more regular water, H2O, than D2O. So as we go looking for the origins of water on the Earth, we'd like to find other bodies that had potential for colliding with Earth that have the same D to H ratio. And we have found this in various asteroids. So it is quite likely that asteroids played a significant role, I'll say it that way, in bringing water to Earth, because they have the same D to H ratios that we find in Earth's oceans. A little further out, past the orbits of the gas giants, we find the methane freeze line. And so inside that, methane is gaseous. And we see evidence for that, for example, in the coloration of Uranus and Neptune, where methane is absorbing red light and gives them their slight bluish color. So all of this is happening. The solar system is different, largely because of where things formed. Bennu, it appears, formed outside the water freeze line, which would account for the water in its makeup. And so we can say within some boundaries, we can take some pretty good guesses about where things formed, certainly small bodies, based on their water content. So let's go back now. Let's go back. Okay, so OSIRIS-REx. Enough with Bennu for a moment. These are some of the instruments on OSIRIS-REx. It had an infrared spectrometer, for example, the OVIRS spectrometer. And OVIRS could measure things like molecular water. It could give us albedos and that kind of thing. And so the published papers that I've seen at this point talk about the albedo retrievals that it has done, and they're pretty consistent with other measurements that have been taken. Fairly dark surface, right around 4% albedo, slightly brighter than Rygu. Now, I mentioned that we have other observations of asteroids and comets as well. Some we have sample returns. Hayabusa 2 brought back samples of 162, 173 Rygu. And so that was not as much material as we've retrieved from Bennu, but I believe that was the first small body sample return mission. We also have observations from SOFIA Stratospheric Observatory for Infrared Astronomy, and from the Spitzer Space Telescope of small bodies Iris and Massalia. And these show clear evidence of water bands in the 6 micron area. These are surface measurements showing clear evidence of water. So I apologize for skipping through here a little bit, but let's go back. Let's see if I can quickly move forward here and get to a spectrum. There's nothing I like better, showing a spectrum. Of course, I always lose my audiences at this point. But here you see of asteroid Iris, we see in red, we see SOFIA measurements from the SOFIA high altitude aircraft infrared spectrometer. And in blue here, we see the Spitzer Space Telescope spectrum, infrared spectrum of Iris. And here you can see we have a significant increase in the baseline continuum, which is indicative of 6 micron water. And so this is what we expect to see for Bennu. Now I'll just skip around here a little bit. There we go. So out of the thousands of near-Earth asteroids that are of any appreciable size, how was Bennu selected? We could have gone anywhere, right? And the answer is that with some size cutoff, we looked at 7,000 near-Earth asteroids that are Earth crossing, that pretend some possibility of hitting Earth. From those was selected 192 that had optimum orbits, so we could actually get to them in a reasonable amount of time with a reasonable amount of fuel and bring samples back. Of those, and sorry, this is a little formatting error here, we looked at asteroids with diameters greater than 200 meters. That makes them easier to orbit and to collect samples. Something larger than 200 meters in diameter, and there are 26 of those. Of those 26, there are 6 that are carbon rich, carbon being an important element for forming life on Earth. And out of those 6, Bennu was selected. So there was actually quite a rigorous analysis campaign that went on to select Bennu over the other asteroids. Bennu is also interesting because it's it's only 500 meters in diameter, so it doesn't have much gravity. It's held together rather loosely. And in the observations, in the imaging observations of Bennu, they noticed little bits of light that looked like stars that they couldn't identify. And it turns out that Bennu is constantly losing material, having tiny rocks and other sand type sized material floating off into space, most of which eventually lands back on the surface. But there's a fairly active surface apparently going on with Bennu where it's kind of attempting to get rid of some of its material, but that material really falls back to Earth. We also know of asteroids, we believe, or at least asteroid belts around other stars. And there have been some JWST images of Fomalhaut, about 25 light years away. And there was a planet that they thought they were seeing, and they named it Dragon. And it turns out that's probably not a planet. That's probably an asteroid belt with much smaller material in a ring around Fomalhaut. So the idea that there are small bodies that come together in accretion, create larger bodies, create protoplanets, and eventually planets, appears to be a process that happens not only in our solar system, but in other solar systems. So I think I'll end there. And perhaps if there are questions in the chat, if you'd like to throw your questions out, we can see if we can answer them.
Luke, can you speak about this finding that Bennu may have made up an early water world in the solar system?
It's quite possible. Water is ubiquitous through the solar system. Hydrogen is the most abundant element. Oxygen is fourth, I think, abundant. We find water almost everywhere we look, and we find it in abundance. Of course, we found it on Enceladus. We believe through our physical models that it exists below many of the surfaces of many planets. Certainly exists below the surface of the Earth. We find water in the deep craters of the Moon and Mercury. Water is ubiquitous. So with some initial, I'll call them estimates, it may be that there's a fair amount of water in the bulk composition of Bennu, and perhaps it was in fact a water world somewhere in its development.
Interesting. I wonder if it's left any evidence anywhere else, though.
If Bennu has left evidence?
No, the existence of the water world. I wonder whether the same material we'll find elsewhere.
Well, we infer a lot of this stuff. Of course, we don't see these water worlds, at least in our solar system. On the surface, Earth is the only surface in the solar system that has liquid water flowing on it currently. But we have ground-penetrating radar that sees water aquifers on Mars. We have evidence from magnetometer readings and other visual observations that there's more water than than all the oceans of the Earth under Enceladus. Europa and Enceladus now, we believe we have evidence from their water ice geysers and so on. So it's just everywhere. And no accident then that asteroids that formed far enough away from the sun also formed with water ice as part of their composition.
Yeah, indeed. Well, that was great, Lou. Thank you so much. And I hope you'll keep us up to date with any further research about the Bennu material.
Yep, we'll do.
Because I was reading one scientist that said he thinks they've got at least a decade's worth of study ahead of them on the material. So it's
Pretty
going to be really exciting to follow that story. We've lost your sound, Lou.
Yeah.
Oh, I'm still here. I'm still here.
Oh, okay. Right. Okay.
Yeah, of course. We've also now got a probe on its way to a totally different type of asteroid, and of course that's Psyche 16. Is it Psyche
Of
16?
course. Of course.
Yes, which is thought to be the core of a long dead protoplanet, which could be
Yeah.
very interesting.
Maybe.
Yeah.
Great.
So we'll see. Yeah,
So
we'll see.
Psyche
Like I said.
Yeah. Yeah. Absolutely.
Psyche then is the remains of a differentiated asteroid that was part of a protoplanet formation that broke apart, but had time for the heavy stuff to sink to the center. And so what's left is that core, that differentiated core. So we'll see.
Absolutely. Yeah, I do apologize, viewers, for somebody trying to beam me up again in the middle of all this. They're not succeeding.
Yeah.
I don't know why this is happening.
Yeah.
I really
Buy your glow in the dark handy while they're in the stores.
Yeah, so I've got no idea why this is happening. I assume it's something up with my camera, which is getting on in years, admittedly. But there we are. Thank you so much, Lou. Really interesting, and do keep us up to date with all the latest about that.
2 excellent talks.
Yeah, and I'm about to spoil that by doing a terrible one. Okay, so moving on. And because I was a bit delayed this evening, I don't know what was said earlier, but don't forget we have the Space Oddities merchandise for sale, and we'll just give you a quick revision of that before we move on to the next bit. So don't forget we have the Space Oddities T-shirt as always, and full details of how to get this are in the description of the video. You can scan this code, and if you look in the chat now, you'll see a link to go and get your very own Space Oddities T-shirt for the paltry sum of £20, which includes UK postage and packing. We have the Space Oddities hoodies, which are quite delectable, in 2 designs, the slip over the head or the zip up version. The slip over the head version has the design on the front, and the zipper version has the design on the back. You can scan the code here, look in the description of the video, or if you look in the chat now, you should see a link to that. And this is the latest addition to our range of merchandise, which we will be expanding towards the summer. The Lapel design T-shirt with the design on the front, on the position of the lapel. 10 colours available, same price as the normal T-shirts, £20. But if you want a long sleeve version of that, please then add £3 to the total, making these £23, including UK postage and packing. Any foreign orders for any of those, please add another £10. So there you are. So that's the delightful range of merchandise. We've got some more up our sleeves.
And can I just say on the long sleeve shirt, if you look on the order page, there is a drop down menu where you can select the long sleeve shirt, and it changes the price to add the £3 on.
Yeah, that's right. That's right. Thank you, Michael. So there we are. So that's the merchandise. Obviously, we would like to say a big thank you to those of you who buy us coffees every week. And I noticed that we've had a few scans tonight. So thank you very much for that. As you know, all the money that you kindly donate to us goes towards keeping the show running. So that's much appreciated. Just a final reminder about that. You can buy us a coffee by scanning this code and look in the description of the video or look in the chat, and where it should have appeared as if by magic. So there you are, and thank you very much. It is appreciated, because obviously we have bills to pay like any other YouTube channel. Nothing comes free these days, and all of your money goes towards those bills and keeping Daz in burgers. So there we are, and we're going to move on now to the news, and we've got a bit of an extended news this week. There's been such a lot happening recently, and this isn't even all of it. So I've just picked out some interesting stories for this week. So let's run the news. Let me just set myself up here as well. Okay, so the first story we've got. New scientists announced this week that CO2 has been detected in the atmosphere of Callisto. That's right, carbon dioxide has been detected running over the entire atmosphere of Callisto. Now, I don't know whether you can shed any light on this, Lou. I was a bit confused by this because it's not new news. Because if you go back in time to February the 4th, 1999, the announcement of a carbon dioxide atmosphere on Callisto was discovered by the Galileo probe in the 1990s. So new scientists have taken 24 years to get round to reporting this. Do you know anything about this story, Lou?
I don't.
No.
I wonder. I mean, it's always good to corroborate measurements.
Yeah.
If there was only one set of measurements many years ago, you want to corroborate it for two reasons. One is to verify the initial measurements, and the other might be if you can get abundances from both measurements to see if there's been any change over time. But otherwise, I don't really have any.
I mean,
anything to
I wanted to read the New Scientist article to see exactly what they were saying, but most of the article's behind a paywall. So, and I couldn't find reference to it anywhere else. New Scientist seemed to be the only magazine with this.
This is not in keeping with good open science.
I totally agree with you. I totally agree. So there we are. But New Scientists say there's been a discovery, and it does say astronomers spot carbon dioxide atmosphere on Callisto. That's the actual headline. So it's not like they're saying, new findings about the carbon dioxide atmosphere. It's saying astronomers spot carbon dioxide atmosphere on Callisto. So I don't know. So there you are. Anyway, moving on. The next story. This was an interesting story. For the first time, surgery has been performed on the International Space Station remotely from Nebraska. And you can see the guy there sitting, guiding a robot to doing surgery. Now, don't worry, he's not doing real surgery. He's doing simulated surgery on a piece of rubber. And this is a robot that basically holds or will hold human flesh with one claw, and the other one will cut into it, as it were. Why is this important? Because it was a fantastic demonstration, which went exceedingly well, apparently, that surgery can be done remotely over long distances. Because when we embark, as we surely will, on long space voyages to places like Mars, a surgeon will need to go along, or somebody who knows a lot of medicine anyway. But this was a demonstration that perhaps that may not be necessary, that surgery can be done remotely. So they attacked this piece of rubber with the surgical tool, and it was a complete success from Nebraska, from the guy in Nebraska, 250 miles above his head. There was the International Space Station. So, they are starting to prepare for medical events that occur on space voyages. And
at least in low Earth orbit, I don't know what you would do if you had to deal with the delay.
Exactly, that's what I was thinking.
Going to Mars.
Yeah. I guess
I don't know if my health insurance would cover
that. Oh yes, of course. You've still got that quaint thing called health insurance, haven't you? Yeah, I forgot about that.
Oh yes, yes. I'm yeah.
But it shows that it can be done. I think that's the important thing. That in an emergency, if your surgeon was the person who was on the table, then it could be done remotely. So this was an important step forward, and the first time it had really been tried. Okay, what have we got next? The Kuiper Belt objects, Eris and Makemake, they have an icy surface, of course, being that far out in the solar system, on the edge of the solar system. But astronomers have found that the ice on both of these bodies has recently been altered by an internal heat source. So there is still activity on these presumed frozen bodies, and they're thinking that perhaps this indicates yet again the presence of underground oceans on both of these bodies. I think these are amazing discoveries, considering how far away these objects are and how faint, that they can do a spectroscopic analysis and work out that this ice is not sort of billions of years old. It's been modified in some way by some internal heat under it. So that was quite interesting as well. Any thoughts on that?
What's interesting about this is we used to think when Eris was first discovered, it was estimated that it was slightly larger than Pluto.
Yes.
Okay, which was part of starting the big debate about what's a planet and what's not.
Mm.
And we do see a lot of dynamical movement on the surface of Pluto.
Mm.
Okay, very, very, very cold ices. So I don't know if this is evidence of underground oceans on Eris or Makemake, but it's one possibility.
Yeah.
So
Yeah, because we believe, don't we, that Pluto does have an underground ocean, and these are similar bodies. So who knows? But anyway, quite an interesting idea. I mean, it is only speculation that the heat is coming from an underground ocean, but anyway, quite interesting. Just in case you're wondering about the size of these, Makemake is 889 miles in diameter, and Eris is 1,445. So there they are. Those are artists' impressions, of course. We have no idea what they actually look like, but it's probably not too far from the truth. They're probably inspired guesses, given what we know about Pluto. Titan next. We're moving on to Titan. Now, Titan, as we know, is a bit of a bizarre body, and as we know, it's got a very, very, very thick nitrogen atmosphere. It's covered in hydrocarbons like ethane and methane, and we've got these hydrocarbon lakes as well. But also, it's long been thought, or at least for a while, that Titan, speaking of which, may have an underground ocean. And the question, therefore, always arises, is there life on that underground ocean? Well, you have to then ask the question, where would the materials for life for life come from in Titan's underground ocean? If there were life there, where would the materials come from if you've got this ice covering the surface? And because Titan is an incredibly cold place. And how would the materials get into the underground ocean? Well, one way that they could do that is by cometary impacts, with the material gradually percolating down through the rock and ice into the underground ocean. And a couple of years ago, there was an estimate that in a typical cometary impact, maybe 60% of the materials from a comet might percolate downwards into the ocean if it is there. Now we know that comets are the harbourers of organic materials, so this is not beyond the realms of possibility. However, there's been a new look at this question, and the news is not good. So this is the interior structure of Titan: an organic rich atmosphere and surface, water, ice, and clathrate shell. There's the global subsurface ocean, and then you've got a high pressure ice 6 shell under that, and a hydrosilicate core. And they've done new estimates about how much material would actually percolate down into the ocean from the surface from things like cometary impacts. And they've come up with the estimate. They talk about the DNA base, DNA molecule. What am I talking about? Amino acid glycine. This is just one example they looked at, and they estimate that only 7,500 kilograms of glycine would actually reach the ocean each year. And that may sound a lot, but spread over the surface of Titan, it isn't a lot. So what they're basically saying is that it's probably not that likely that things like amino acids will get down to the ocean in sufficient quantity to bear life in that ocean. Any thoughts about that, Lou?
I would not give up on Titan yet.
Good, wise words. Wise words.
Oh,
Yeah.
goodness. It has the most amazing chemical atmosphere. The surface is not necessary. It's frozen in terms of water ice. That's fine. But in terms of hydrocarbons and nitriles, they sit on the surface very fat and happy. And these are I haven't read the research, but these are theoretical arguments. And of course, we there's the possibility that there is microbial life. We're not talking about, co- cognitive aliens.
Yeah.
Microbial life that could exist in the presence of methane as a food source and a byproduct.
Right.
So let's read critically, but let's wait for the preponderance of evidence.
Yes.
Which will come from the Dragonfly mission.
Absolutely, and which we're all looking forward to. Yes, because the only way we're going to know the answers to these questions is to go there, isn't it? Really. So let's wait for Dragonfly. One of the, I think, the most exciting missions coming up within the next decade. Yeah, definitely. Okay, moving on then. You may remember that we had a great launch last week of the Odysseus lunar lander, launched by SpaceX towards the moon by the company Intuitive Machines, part of the NASA Commercial Lunar Payload Services program. It's got lots of interesting experiments on it. And just to show you some footage taken from the lander, taken from the Falcon, Falcon 9, looking back at the Earth there, and see the Earth spinning there, and you're looking at the landing legs of the lander, and then fantastic view there, and there is the moment of separation that Odysseus went on its way, and the latest news is that its engine's been commissioned. That went well, and the lander is due to arrive at the moon on February the 22nd. And as ever, if it occurs at a sociable hour, we will bring you live coverage of Odysseus on the moon. 50% of all landers sent to the moon have failed, exactly the same number that have failed going to Mars. So it's not easy to land on the moon nor on Mars. But I just thought I'd show you this lovely video. A couple of nice photos as well. This is taken from the lander, looking back at the Falcon in the background there. Lovely image. And then lastly, another one from the lander looking down at the landing legs. And beautiful photos there from Intuitive Machines. So we're looking forward to the landing of Odysseus on the moon on February the 22nd. Put it in your diaries, because as I said, if we can, we will cover it live.
Really, really good quality photos from there as well.
Yeah, fantastic.
Yeah.
Now, talking about landing on the moon, China are launching Chang'e 6 to the moon in May. And this is a lunar sample return mission. So they want to take some samples of the lunar regolith and bring it back to the Earth. Again, an important mission to grab some of the moon and bring it back to the Earth and study it. That's happening in May. And we will cover that for you here on Space Oddities, of course. Moving on.
Just borrow some of ours. I mean, that would be fine.
Sorry?
You could just borrow some of ours.
Well, that's true. Ooh.
You go to all that muss and fuss.
Now, this is an interesting one. This launched within the last week. This is a company called Astroscale and their spacecraft ADRAS-J. That's a lovely photograph there.
Yeah.
And this is an experiment, the first tentative experiment in cleaning up space garbage from Astroscale. And they will. This spacecraft will approach a redundant Japanese launching stage, and do some measurements and examine it from close range as the first step to cleaning up this space garbage. It's really a technology demonstrator to prove that the ADRAS-J spacecraft can maneuver very closely to a piece of space junk. There won't be any attempt to do anything with it at the moment, but small steps, eh? And this is a problem that we know needs urgent action.
Yeah, we certainly do. If I can just jump in there, Andy.
Yeah, sure, of course.
Of course, we're talking, this is all about space junk. And I just want to bring this up. I'm just going to bring up a... can you take yours down, mate?
Yes, 1 second. Give me a second. Okay, yeah. Okay, there you go.
Here we are. Now this, it's not an X-Fighter off of, or T-Fighter, whatever they call them, off of Star Wars.
You're not a Star Wars fan, are you, Daz? Let's face it.
This is an ESA ERS-2 satellite. It's an Earth observation satellite. It was launched in 1995. It operated for 16 years, and its mission ended in 2011. Now, the reason I brought this up is in 2011, once it was decommissioned, they spent 2 months doing deorbit burns and maneuvers, those to bring it back into Earth safely. Now it's due to, of course, so this is 2011. It's due to re-enter tomorrow,
Oh,
approximately 1519 GMT, which is EST,
mm,
but it has a plus or minus of 19 hours.
19
Uh,
hours.
Yeah, so that's you're talking about half, and it can come down anywhere in virtually half an orbit.
And let me guess, they don't know where it's going to come in.
No, because like I said, with 18, you can't with
No,
with that sort of with 19 hours. There's no way you can predict where it's going to come from.
No.
So hopefully they've chosen a corridor that's virtually all sea. Just keep an eye out for this one. As I said, it comes back tomorrow. But of course, this all comes back down to what you were talking about: space debris.
Yeah.
And the mitigating circumstances that some people are going to.
Sure.
There has been talks of in future people who put anything into space, they've either got to do a controlled deorbit,
Yes.
or they can have an uncontrolled deorbit, just let it fall back to Earth, but it all must be planned out, or they can shove it up into space and just put it into a higher graveyard orbit.
Yeah.
Now, this one, just a quick question. Because this happened in 2011 when they did the deorbiting stuff, and ever since then it's been flown. Is this a controlled deorbit, or is this an uncontrolled deorbit with a 19-hour discrepancy? What do you think?
I think they should ask an authority on uncontrolled deorbits. They ought to ask the Chinese.
Yeah, they're the experts.
Yeah, they're the experts on just saying, what the hell, we don't care when and where it comes in. I don't know. I mean, they've done the initial deorbiting, haven't they?
Yeah.
So I would class this as a controlled one, because if they hadn't done that, it would literally come in anywhere at any time.
Yeah.
So
Yeah, as I said,
I don't know what the error bars are on this, but
excuse me.
look at these images. You can imagine kind of turning the spacecraft one way and then another, getting more of its face toward in the ram direction where it would slow down more, or making it thin with respect to the ram direction. And I imagine that would play a significant role in when it deorbited.
Sure.
So I don't know.
Yeah, because Harry's hit the nail on the point here. It's the reason that we've got such a big discrepancy is because it's coming down so slowly, and it's been in the higher reaches of the Earth's atmosphere. Of course, with solar weather, the atmosphere has expanded and contracted. So sometimes it's been sat in thicker atmosphere, which has slowed it down.
Yeah.
And then it shrunk again, and this has been pulsing all this time. So as Harry said, I think I can put it up. Yeah, it says plus or minus 19 hours, shape of object and interaction with the atmosphere, spin and skipping in the atmosphere.
Yeah, thanks,
So,
Harry.
yeah,
Very true. Yeah,
so,
absolutely.
but yeah, I just wanted to add that into the as I said, that people are talking about it now, and it needs to be sorted. Right. Sorry,
Okay,
Andy.
right, let's
Thanks
go
for
back to the news. Get back to where I was. Okay, so that's the space garbage thing. Anyway, moving on, the European Space Agency are continuing to prepare their Hera mission. Now, you may remember the DART mission, which proved it possible to deflect an asteroid from its orbit. In that case, this is Dimorphos, the little moon, or little two moons, should we actually say, of Didymos, and the DART spacecraft slammed into it and changed its orbital period by 23 minutes, if I remember rightly. This is a test of the first test of planetary, sort of the planetary defense. that if we were threatened by an asteroid, we may be able to deflect it from its trajectory. And it was certainly a success. The HERA mission from Europe is going to fly out to Dimorphos and have a look at the aftermath of that collision to find out exactly what happened afterwards. And it's going to launch in October. Obviously, we'll cover it here on Space Oddities if we can. And it's going to rendezvous with Dimorphos in 2026 to get a close look at exactly what the collision did to that little pair of moons, actually, isn't it? So there we are, and we will see. Okay, moving on. This is the story of a quasar, APM 08279 plus 5255, the biggest water reservoir ever found beyond the Earth. This is a quasar, which, as we know, is the core of a young galaxy with an incredibly voracious black hole at its center. And this has been found to be the largest water reservoir off the Earth because the intense temperatures of the accretion disk around the black hole generate a load of X-rays, which works on the gas, and basically you get water condensing out of it. And the volume of water that's been found around this quasar is quite staggering. It's 140 trillion times the water of all of Earth's oceans put together. So it's absolutely amazingly wet. And of course, this raises all sorts of interesting questions about, again, something we talked about earlier, water in the universe and where it comes from. And this has been the largest amount of water ever discovered around a quasar. So that's quite fascinating. And that was an artist's impression. This is an image of the real thing. This is the quasar 12 billion light years away. So, very, very far away indeed. You can't see the water, obviously, in this image. You'd need to do a spectroscopic analysis of this. This is, I think, a visual image. But there we are. So this is the largest water reservoir ever discovered off the Earth. Now, you may remember the spacecraft Varda. We talked about this ages ago. So this is a company that are doing experiments, or were doing experiments in space, making drugs in space, the type of drugs that you cannot make on the Earth because of the gravity. And they've been making a drug for retroviruses like AIDS to treat diseases like that. And the type of drugs they were making were you just can't make on the surface of the Earth. And it was again a technology test to show that it could be done. And they managed to make these new drugs in this spacecraft automatically in orbit. But when they came to return the spacecraft to the Earth with the drugs in them for analysis to see exactly what it is they managed to create, the FAA in America refused them permission to land because they were worried about what might be inside the spacecraft, that they might have created something, a bit of a biohazard, if you like, that could threaten life on Earth. So they were denied permission to return the spacecraft through the atmosphere. And that one's been rumbling on, that controversy, for how long ago was that, Daz? It was a few months.
Well, that started just before, a little while before the OSIRIS-REx return.
That's
It's
right.
been going on for quite a while, yeah.
Yeah, it's been going on for a couple of months at least. Anyway, the good news is that Varda have now received permission to land the spacecraft from the FAA, bring it back to Earth, and I think they may have already done so. I think it was scheduled for today or maybe even yesterday. But the good news is that Varda will have got their manufactured drugs back that they can study to see exactly what they've created. And this is great news that, private companies can launch these spacecraft. And Varda isn't a big spacecraft by any means, with the machinery and computers inside to manufacture these badly needed drugs for all of these horrible illnesses. So that's good news.
Andy, did I hear that it's actually coming down, or was that something else coming down in Australia?
Yes, I think it was, Daz. Yes.
Yeah, I think they've moved it to. They don't want it on their doorstep, so they're going to dump it in Australia.
That's right.
Sort of thing, but
well, I mean,
not in my backyard.
We did the same with our convict, so
Well, that's right. Yeah, that's right.
the continuing awful tragedy of Ingenuity. As you may know, the Ingenuity helicopter on Mars was flying over a dune field, descended, couldn't work out exactly where it was because the dunes were quite featureless, and managed to crash its rotors into the ground. And NASA have been trying ever since to work out exactly what the damage is. The inset image there is the shadow of one of the ends of the rotor. And as you can see, the end of one of the rotors is severely damaged. But it gets worse because they've discovered this week that actually one of our rotors is missing. One of the rotors are actually snapped off altogether, and it's to be seen laying a few meters away on the sand. And so this is, I'm afraid, the end of the road because they definitely can't fly with a missing rotor.
Oh,
So-
that's a
I
shame.
hate when that happens.
Sorry?
I hate when that happens.
Yeah, I
Yeah.
do as well. Yeah, absolutely. It's like losing your favourite lawnmower, really, isn't it? It's, you know,
Upside down.
upside down, yeah. So there's no way forward from this. Ingenuity is at the end of its mission. It's over.
Well,
But what a tremendous success story
Oh, yeah.
exactly.
Ingenuity
Yeah,
is.
exactly.
Yeah.
Yeah.
This mission, I think you'd agree, will be talked about for many years to come. And as not only the mission where we found that we can fly fly aerial vehicles in the incredibly thin atmosphere of Mars, but we can do so repeatedly. And because don't forget that Ingenuity they thought they'd be lucky if they got 5 flights out
Yeah.
of it before it succumbed to Martian conditions, and it flew 72 times, and has been a real pathfinder in every sense of the word, a real trailblazer. So there we are. So unfortunately, RIP Ingenuity. We'll miss you.
An amazing testbed, though.
Yeah,
Yeah.
an amazing bit of engineering, as it always is.
Yep.
Now, here's a new winner of the prize for the brightest object in the universe. So let me ask the panel. So what type of object do you think is the brightest object in the universe?
I would say a quasar or a blazar.
Yeah, I'd say quasar.
Yeah,
Quasar.
it is a quasar. And how bright do you think this is?
40 watts.
Is that old money, Daz, is it?
Excuse me. Well, anyway, let's look.
About
So
100 billion suns.
how many?
100 billion suns.
100 billion suns. Oh, that's a big number. Okay, let's have a look. So this is Quasar
12
J0529
billion.
435 551. It's 12 billion light years distant, like the other one we were looking at earlier with the huge water reservoir, about the same distance. It's consuming an enormous amount of material. It's consuming one sun's mass of material every day, which is quite phenomenal. And because of that, it's 500 trillion times brighter than the sun.
Wow.
500 trillion.
500 trillion
That's-
times brighter.
That's pretty bright.
That is
Yeah.
Yeah, your Ray-Bans are not going to cope with that, are they?
In fact, that may answer a question that Ian had earlier about the quasar. When we were talking about water, he said, could there be life in the quasar? I think that answers your question.
Yeah.
Yeah.
500 trillion times brighter than our sun, which is quite phenomenal. And the black hole itself in the quasar has got a mass of 17 billion solar masses.
So how would you set the exposure on the camera?
Yeah. Of course, that intensity of photons, I mean, that is pretty damaging, isn't it? Let's be honest. That would be pretty lethal at close range. So there we are. So that's now officially the brightest object in the universe. Some good news.
Hey guys, I have to run and catch my flight. Just wanted to say great show today.
Oh, thank you very much for your presentation and your well, whatever, your knowledge as ever. Have a safe flight.
Yeah, safe journeys.
Thanks everyone.
Yeah, see you next week.
Yeah.
Now, some good news for those of you who hate Starlink satellites because of the interruption to astronomical imaging and the damage that they create with astronomical imaging. And of course, it's amateur as well as professional astronomers who are concerned about this. Well, now a new group has taken up the challenge, and it's the United Nations. They are actually officially taking up the problem of light pollution from satellite constellations. Delegates representing 102 countries, they, believe it or not, they came to an agreement about this. Can you imagine 102 countries agreeing about anything else? To discuss the impact of all these huge new satellite constellations, of which many are planned. And they're having a meeting this Thursday, an initial meeting, to discuss the issue. And in case you don't know what the problem is, the image on the left shows you an astronomical image, and all of those lines crossing the image are from Starlink satellites. So, and this is just the Starlink constellation. Many constellations are in the works. Amazon are putting up a constellation. The Chinese are putting up, I think, 3 constellations of satellites. And they've all got thousands of satellites. And basically, if we allow this to continue, there won't be any astronomical imaging from the Earth because of because exactly what you see in front of you.
Yeah.
These satellite trails. So there we are. So the United Nations is officially taking it up as something to examine and work on and come up with some recommendations.
Yeah, because also with this, you've got to think about launch. When you're launching anything, you've got to make sure you're not going to collide with anything.
Yeah,
And
absolutely.
this is on several launches they've had to stop the count just because there was a possibility of a possible collision. So yes,
absolutely. So we're really messing up low Earth orbit, aren't we? What with the debris and these huge constellations of satellites. So anyway, but let's not get too despondent. This is good news that the United Nations have taken it up. So we will see what happens, and of course we'll follow this story for
but
you.
they're also deorbiting a load of
Yes, that's
satellites,
right.
aren't they? Because they're faulty apparently. So
yeah,
but they'll be replaced, unfortunately.
yeah. I mean, they're only deorbiting 100 out of 5,200 that they've launched so far.
It's a start.
It's a start. It's a start. Some more good news this week. And we like bringing you good news here on Space Oddities because, after all, it's a wonderful universe and we like wonderful news. The wonderful news here is that the first 18 mirror segments of Europe's Extremely Large Telescope have arrived in Chile after a long journey by sea from France. And they're on their way up to the site of the Extremely Large Telescope, where they have a facility for silvering the mirrors, because at the moment these mirrors are unsilvered, but they will be silvered up on site, as it were. And it may sound as though this is, a lot of segments arriving, but it's only 18 out of 798. So the primary mirror of the ELT will consist of 798 of these hexagonal segments. But, this is the first shipment of them and many more to follow.
Need a bigger lorry.
We need a bigger lorry, a bigger boat, actually.
Yeah, boat. Lorry.
In case you're wondering what the place is looking at, well, here's an image of the Extremely Large Telescope under construction. This is actually quite an old image now. This was taken last August, but you can see the sheer scale of it. If you look at the vehicles down there, you can see what an enormous cathedral size building this is. And well, I mean, in fact, if you think about it, I think it's a cathedral in more than just a metaphorical sense. This is a cathedral of astronomy. It's the largest telescope ever built by humans, and it has a 39-meter mirror, and it's going to have the most advanced adaptive optics system in the world, and it will probably be the biggest telescope ever built on Earth, because it's difficult to see that anybody's going to build anything bigger. And we're very proud of the fact that it is a European project in Chile under the auspices of the European Southern Observatory, which is in Chile. And the first segments for the primary mirror have arrived safely after their long journey by sea.
Can I just say, I think it could be more like you say, it would be a cathedral to science.
Yes, that's very true, Michael. Yes, absolutely. It will be a cathedral to science, definitely. And there we are. And just lastly, to finish today, many congratulations to SpaceX for the 300th flight of the Falcon 9 rocket. The rocket that has transformed the space industry by bringing the price of getting a kilogram of mass into orbit down dramatically. Don't forget, at the time of the space shuttle, it was costing around $27,000 to put 1 kilogram of mass into orbit. And we're not exactly sure of the cost for the Falcon 9, but it's brought it down at least tenfold.
Yeah.
So this is great news. This is probably the most successful rocket. No, it is. It is the most successful rocket ever built. Because, as we know, not only did they launch it 300 times, but a very high percentage of those launches have resulted in the first stage being recovered and reused. And many congratulations to SpaceX. And of course, the days of the Falcon 9 are numbered, because the Falcon 9 and the Falcon Heavy, its bigger sibling, if you like, will both be replaced by SpaceX's Starship when it comes into service, which is capable of lifting around 120 tons of payload at a time into low Earth orbit. And just incidentally, it now looks like the next test flight of the Starship will be the first week of March. And we will bring that to you on Space Oddities if we can. And this time, even Elon Musk says he reckons they've got about an 80% chance of getting the Starship into orbit this time. If they do, it will be a complete world game changer, because everything will change immediately.
Yeah.
Because there won't be any need for rockets like the Falcon 9 and those from other companies, because SpaceX will just clean up in the orbital launch market.
Yeah.
Because if they can pack 120 tons of payload, the cost of doing so to each customer will be absolutely reduced even further. And basically, for orbital launches, I think SpaceX will be the only game in town, or one of the few in town.
Yeah. And just to show how successful the Falcon 9's been, it's now over 200 successful launches and landings.
Yeah.
It's been over 200 launches ago that there was any actual issue with any of the rockets. So
Yeah.
that just goes to show how long ago we had a problem with a Falcon 9.
Yeah, absolutely.
So absolutely amazing success
So
rate.
well done, SpaceX. Many congratulations. A fantastic achievement.
Yeah.
And, SpaceX had indeed transformed
Mhm.
the whole of the space industry and continue to do so.
Yeah.
And once Starship enters service, all bets are off. It's going to be an amazing era for rocketry and satellite launches.
Yeah, I just thought I'd like to pop this up from Harry. It says NASCAR line drawers to 39 meter scope. Neat. So yeah, the history of the history of astronomy.
It's very pretty neat.
So,
Pretty neat, Harry.
And can I just thank Harry for the lovely message he left at the beginning of the show? Thank you very much.
I didn't see that.
Much appreciated.
I'll have a look at that.
So yeah,
So,
thank you very much.
So there we are. But that's it for the news. A bit of an extended news, but there's been so much going on recently, and that wasn't even all
That's
of it.
only just scratching it, isn't it?
It's only just scratching the surface. We can't possibly, as much as we'd like to, we can't possibly bring you everything that's going on. It's because it's just accelerating exponentially. I mean, how many launches have we had in the last week, Daz?
Yeah, exactly.
Well, we were just talking about it, and there's been in the period when we were talking about when we covered the launch, in 24 hours there was 5 launches.
5 launches in 24 hours.
I watched all of them. So.
And a few years ago you would have been 5 launches in 25 months.
Yeah, exactly. Yeah.
So there we are. So Michael, your thoughts about SpaceX's 300th flight then?
Oh, absolutely amazing. It's just incredible the advances they've done in the last few years, considering their shaky start to begin with. So to get off the ground, as it were.
Yeah, absolutely.
Talking of launches, Andy, I'd just like to say that on this day in 1962, Friendship 7 was launched.
Was it really?
Yeah. So,
my goodness me.
Yeah.
Yeah. I'd like to say I remember that. I don't.
No, not me.
No. But I remember seeing definitely later splashdowns.
Nice.
I remember seeing Mercury splashdowns
Oh,
on
right.
the TV.
Yeah.
So that wasn't that long after.
Yeah.
And certainly Gemini's. I remember the Mercury and Gemini's.
Mm.
I had an Action Man
Yeah.
Mercury capsule. Yeah. It wasn't made for Action Man. I think it was made, that American copy of G.I. Joe.
G.I. Joe.
Oh, yeah.
Because Action Man was ever so slightly bigger than G.I. Joe, because he was British, of course.
Yes.
And
Sterner stuff.
Action Man never quite fit in the seat inside the capsule properly.
Mm.
But anyway, there we are. Okay, listen, my pleasure, guys, about the news.
Thank you. That was great.
It's
Oh,
there's
Ian
just so
says
much going on.
Ian says 21 likes and 21 viewers.
That's fantastic. So
Yeah.
don't forget to like and subscribe, because
Yeah.
it really, really makes a difference to our viewing. Because the YouTube algorithm notices us more if we've got likes and subscriptions, obviously. So if you could remember to like, subscribe, and comment in the video afterwards, that would be fantastic, because the comments count towards how far across YouTube our videos get distributed and to whom. So
Yeah.
likes, subscriptions, and comments in the video after the event are always much appreciated, and we do love you for doing that, because onwards and upwards, it enables us to move onwards and upwards to the future.
Yep.
And speaking of which, I see we've had quite a few scans this evening. Thank you to those of you who bought us coffees. It's very kind of you. And there we are. We'll be back next week, of course. So a big thank you to Keith for the first part of his presentation about astrometry. And I presume at some point you're going to be talking about Gaia, Keith, I would guess.
Yes. You and I will need to chat about how to get video clips to work online, because when it comes to parallax, they're very useful to show what's going on.
Don't worry, we'll sort that out. Oh, I
Yeah,
appear to be dematerializing again.
Yeah, but you've got to read it, Andy.
Yeah.
Beam me up, Scotty. And I remember a friend of mine telling me about a play they did at university, and it was a spoof of Star Trek, and the actor playing James Kirk's on stage, and he says, "Beam me up, Scotty," and the stage goes dark, and you hear this enormous scream, and he says, "I said, beam me up, Scotty, not beam me up, Scotty." Well, it made me laugh anyway. So there you are. Yeah.
Right.
Okay. Thank you, Keith, for your continued tsunami of bad jokes. I'm really enjoying them. And, so there we are. And we'll be back. I'm not sure what we've got going on next week. So keep your eye on the Facebook page, of course, where we'll let you know about what's going on. And thank you all for being here. That's what we want to say. And there we are. And don't forget, T-shirts, hoodies, and Lapel T-shirts available. And there we are. Okay, so we will see you for next week. Thank you to Keith again. Thank you, Michael, for being here. Thank you for the gallery I didn't see tonight. Roger, was it a good gallery tonight?
Yes.
It's all Rogers.
Oh, it's all Rogers. No, he would say that then, wouldn't he?
So it was a good gallery.
Yeah. Thank you, Daz, for opening up today and remaining here, even though I know you're not feeling well. So well done for that, you old trooper.
Yeah.
So,
Brave little soldier.
Yeah. Oh, there we are.
Now,
Stop beaming me up now. Okay. Right. From all of us at Space Oddities, we'd like to wish you a very good evening. Have a fantastic week. Stay safe. Keep your eye on the Facebook page for any announcements about what we're doing, because we might do a few ad hoc things for like launches and things like that, depending on what's happening. So keep your eye on the Facebook page. And if you're watching on Facebook, thank you for doing so. I see we've actually got 2 people watching on the Space Oddities page on Facebook at the moment. So thank you for doing that. And we will see you next week. From all of us at Space Oddities, have a fantastic week. Keep looking up, and we'll see you soon. Bye-bye.